Good afternoon, everyone. Thank you for joining us today. Today we're going to be covering some topics from 8th to 12th grade. So I have 8th grade math all the way to about pre-calculus. And the way we're going to walk through this is I'll have the question out there and give you a chance to see if you can do it. And if not, then I'll show you exactly how to do it. Regardless, I'm going to show you exactly how to do all of these problems. And we will end the session with 2 puzzles just to lighten the mood. Thank you for joining today again, and I look forward to spending the hour with you. And let me know if you have any questions as we proceed. Feel free to go ahead and subscribe so that whenever we go live, you get a notification that we're live. So I'll wait for about maybe a minute, and then we'll get started on some of these questions. So what I've done with this is for every question, I've given you the approximate grade that these questions will be relevant, and then the topic that is also related to the question. So if you have any questions on these topics, what I like to do also is, if I notice that there's a topic that no one is able to answer, then the next time we meet, I will go ahead and make sure that I have some questions on that topic again. So Tuesdays and Thursdays will be dedicated to 8th graders all the way to 12th graders. And then on Friday we'll have all grades. But on Mondays and Wednesdays we have 2nd to 7th graders. But on Friday we have 2nd all the way to 12th grade. All right. With that in mind, let's go ahead and get started for today. So I have a table of values, and I'm looking to see how we can create a linear equation for this set of data. We're going to create a linear equation for the set of data that we have. So one thing, just remember that linear equation is in the form y equal to mx plus b. And m represents your slope. And b represents your intercept, which is your y-intercept. Your y-intercept. Okay. I'm just going to wait for a few more seconds, and then I'll go ahead and show you how to do this. Okay, so we have this table below. We want to create a linear equation. The first thing we want to remember is that we're trying to create an equation in the form y equal to mx plus b. And so we're going to first, in this case, we don't have an intercept. Remember that your y-intercept is going to be the value when x is equal to 0. So purposefully, that point is not on this table. So the first thing we're going to do is to find the slope. So our slope, which is m, let's write this, slope, which we label as m, is rise over run, okay? In this case, where rise over run, let's pick, I like to work with positive numbers. That's a lot easier to manage. So this is going to be our rise, or we can say we're going from 16 to 7, or we can go from 7 to 16 and then 1 to 4. So our rise from 7 to 16 is going to give us 16 minus 7. And then our run is going to be from 1 to 4, which is 4 minus 1. This is going to give us 9 over 3, which is equal to 3. So now we have an equation where, in this form, y equal to 3x plus b. Now we need to find out what the value of b is. To do that, we can pick any set of points here. Pick any set of points. I'm going to just pick 5, 19 as our point. So here 19 is y is 19. Okay, so y is 19 and our x is 5, so this is going to be 3 multiplied by 5 plus b. So 19 is equal to 15 plus b. So let's go ahead and subtract 15 from both sides, and then we have 4 equal to b. So now our equation is going to be y equal to 3x plus 4. So we found out the slope, which is the 3, and then our y-intercept is going to be 4. So now let's go ahead and test any of the points to see if this is accurate. I'm going to test this point right here. -2, 2. So y equal to -2 equal to, well, let's go ahead. We're trying to find y, so let's not use -2 here. So y equal to 3 multiplied by -2 plus 4, which is going to give us -6 plus 4, which is equal to -2. So that shows that the equation is correct, because when x is -2, y is -2. If you're not sure, you can try. If you're not sure of your answer, you can try several points. And when you can create this pair of points, then you should be fine. That should give you an indication that you have the right answer. Okay, the next question we have here is factoring by grouping. So we're going to factor these polynomials by grouping. 6x squared plus 12xy plus 8x plus 16y. Let's see if anyone has an idea of what to do here, and then we can try it together and move on. We're trying to factor this by grouping. 6x squared plus 12xy plus 8x plus 16y. Okay, so let's go ahead and write this and start to solve it. So we have 6x squared plus 12xy plus 8x plus 16y. So I'm going to create my groups. I'm going to group right here, and I'm going to group here and right here. So let's factor each of these. We have the greatest common factor of these two terms is going to be 6x. We divide 6x squared by 6x, we have x. And then we divide 12xy by 6x, we have plus 2y. And now we go over here to this expression, this side of the expression, this group here. We have 8x and 16y. Our greatest common factor is going to be 8, so plus 8. 8x divided by 8, we have x. And then 16y divided by 8, we have plus 2y. So now we have rewritten this as a product of its factors. So we can see that we have x plus 2y here, we have x plus 2y. So we can say that x plus 2y is our greatest common factor. So x plus 2y is our greatest common factor, and the other factor is going to be 6x plus 8. So the other thing you can do here is to go ahead and factor 6x plus 8. So let's go ahead and do that here. 6x plus 8. The greatest common factor of 6x and 8 is going to be 2. 6x divided by 2, you have 3x. 8 divided by 2, you have 4. So now this is going to end up being 2 multiplied by 3x plus 4 multiplied by x plus 2y. So this is the final solution, because when you factor, you want to make sure you are expressing these terms in its lowest or simplest form. Let's look at the next example. Are there any questions? If you have any questions, feel free to ask as we proceed. Now we're going to be simplifying some radicals, and this is Algebra 1 and Algebra 2. In some school districts, you may find this in 8th grade, especially if you're in pre-AP. You may see it in 8th grade math. And so this is the expression we're going to simplify. We have a radical here. We want to simplify this radical. Simplify the radical. For those who are joining, welcome aboard. We're just walking through some questions. So we have 5 root 12 plus root 75 minus 2 root 48 minus root 27. You can actually use factor trees to simplify this. If you want, you can express each of them as a product of its prime factors, and that should give you a headway. It should give you a hint on how to proceed. All right, let's go ahead and try this out. So we have 12. Let's go ahead and decompose 12 to our product of its prime factors. We have 2 multiplied by 6, and then you have 2 multiplied by 3. So the general approach I take is I look for pairs of common numbers. So right here I have a pair of 2's, so that's going to give me 2, and then if I have an orphan, then that's going to be my radical. So this is going to give us 5 multiplied by 2 square root of 3. And then let's go to 75. 75, we have 3 and 25. We have 5 and 5. So now we're looking for a group of common numbers. We pick one value out of that. So this is going to give me 5, and then square root of 3, because 3 is, I call it an orphan, or it stands by itself. It doesn't have a pair. So that's that. Then let's look at 48. 48 is going to be 2 multiplied by 24, 2 multiplied by 12, 2 multiplied by 6, and then we have 2 multiplied by 3. So now I have 2 pairs here. I have this set here, and I have this set, and I have this one that sits by itself. So for each of the pairs, I'm going to bring out only one value that represents the set. So this is going to give me 2 multiplied by 2 square root of 3. So this is minus 2 multiplied by 4 square root of 3. And then 27, that's going to give us 3 and 9, and then 3 and 3. So this is minus 3 square root of 3. So now we have 5 multiplied by 2, we have 10 square root of 3, plus 5 square root of 3, minus 2 multiplied by 4, or negative 2 multiplied by 4, we have minus 8 square root of 3, minus 3 square root of 3. So now we have 10 plus 5, because we have a common term here. 10 plus 5, we have 15 square root of 3, minus 8 minus 3, minus 11 square root of 3. So 15 minus 11 is 4 square root of 3. So this is the answer to this problem. Are there any questions about this approach, or are there any questions about this topic, so that I can go ahead and show and repeat anything that I need to repeat? Okay, if there are no questions, let's go ahead to the next one. So we're trying to solve an exponential equation. So 5 to the power of 3x equal to 5 to the power of 7x minus 2. So we're trying to find the value of x in this case. What is the value of x if 5 to the power of 3x equal to 5 to the power of 7x minus 2? So when you're trying to work through a problem like this, you want to find out, to work with exponential equations, you want to make sure that the base are the same. And the rule is pretty simple. If the base numbers are the same, then you can equate the exponents. So here we have 5 as the base for the left-hand side and 5 as the base for the right-hand side. So what that simply means is that we can equate the exponents. So 3x is equal to 7x minus 2. So let's subtract 7x from both sides. So 3x minus 7x, that's going to be negative 4x equal to negative 2. Now we're going to divide both sides by 4 so we can get the value of x. We divide by negative 4 rather, negative 4, the coefficient of x. So this is going to cross out. We have x equal to 2 over 4. We can simplify this further, and that's going to give me 1/2. So x is equal to 1/2. All right, let's try the next one. Feel free to ask any questions as we proceed. Next question, what is the equation? What is the equation of a line that passes through the midpoint of 4, 7 and negative 2, 5 and is parallel to the line y minus 2x equal to 3? What is the equation of a line that passes through the midpoint of 4, 7 and negative 2, 5 and is parallel to the line y minus 2x equal to 3? This topic gets introduced probably in grade 7 if you're a pre-AP student in grade 7, but for grade 8 students that are in academic math. But it's a topic that gets dealt with in Algebra 1 as well. This is one of the coordinate geometry kind of questions. This actually sometimes shows up in geometry as well. So we're trying to find the equation of a line that passes through the midpoint of 4, 7, and negative 2, 5. So the first thing you want to do is find out the midpoint. What is the midpoint of 2 points? So the midpoint is going to be a point that is derived. Let's call it m, uppercase M, equal to x1 plus x2 over 2, and then the y value, y1 plus y2 over 2. So we can make this x1, y1, x2, y2. So generally, when you're looking at the midpoint, you're looking at the average of a set of points. So the midpoint here, let's call this m, is going to be 4 plus negative 2 over 2, comma, 7 plus 5 over 2. So 4 plus negative 2 is 4 minus 2 over 2. That is 2 divided by 2. That's going to give us 1. 7 plus 5, 12 divided by 2, we have 6. So the midpoint of these 2 points is at the point 1, 6. So now we want to find out how do you tell if a line, how can you tell if a line is parallel to this specific line? The first thing you want to do is write this form, the line in the form y equal to mx plus b. So we have y minus 2x equal to 3. So we're going to add 2x to both sides. And so we have y equal to 2x plus 3. Now, for two lines to be parallel, their slopes must be the same. The slope of both lines have to be exactly the same value. So the slope of the new line we're creating, here is where the slope is. The slope is 2 here. So let's call it slope equal to 2. Then for the equation, the line we're trying to find the equation for, that the formula for that is y minus y1 equal to m multiplied by x minus x1. So what is your m here? Your m is your slope. Your y1 is the y coordinate of your point, and your x1 is the x coordinate of the point. So in this case, we have x1, y1. So now let's go ahead and come up with the equation for this line that passes through the point 1, 6 and has a slope of 2. So that's really what this boils down to. We're looking for the equation of a line that passes through the point 1, 6 and has a slope of 2. So we're just going to go ahead and substitute the values in here. So this is going to be y minus y1 is 6 equal to m, which is 2. And then we have x minus 1. So let's go ahead and simplify this. So y minus 6 equal to 2x minus 2. So we can go ahead and add 6 to both sides. So y equal to 2x plus 4. So that's one way of writing the equation. You may also be told to write it in the standard form, which is ax plus by equal to c. In that case, you're going to write it this way: 2x. So let me take a step back and show you exactly how I'm going about it. So I need to write y equal to 2x plus 4 in the form ax plus by equal to c. So now I'm going to subtract y from both sides. So 0 is equal to 2x minus y plus 4. Now I can subtract 4 from both sides. And then we're going to get an equation that looks like this: 2x minus y equal to negative 4. So that's going to be the two ways we can write this equation, the equation of this line. Okay, now we want to solve polynomials. We want to solve these polynomials completely. It's algebra 2 for sure. We have some algebra 2 here. And you can actually factor this by grouping. But I want you to solve the polynomial equation. You can start by factoring by grouping, and then we can use that to solve the polynomial equation. Let's go ahead and factor by grouping, and then we can solve the polynomial equation. Okay, let's see. We can start by grouping the terms. Let's group this right here, and then group this right here. Okay, so now we're going to find the greatest common factor of these two terms. And looking at it, you can see x cubed, and then you have minus 4x squared. By the way, every topic that I have today, I have some videos in our video library on our YouTube channel, Mathis Tutors YouTube channel. You will find videos that help you with these topics as well. So our greatest common factor here is going to be x squared. So we have x squared and then you divide each of the terms in here by x squared. So you have x minus 4, and then greatest common factor here is going to be minus 1 here, and then you have x minus 4. This is equal to 0. The next thing we're going to do is we now have identified we have a greatest common factor for these two terms. So we have x minus 4 is our greatest common factor, and our other factor is going to be x squared minus 1, and this is going to be equal to 0. Now we have a perfect square here, so what you need to remember is a squared minus b squared equal to a plus b multiplied by a minus b. So now we're going to do that for x squared minus 1. So x squared minus 1 is the same as x squared minus 1 squared. So this is going to give us x plus 1 multiplied by x minus 1. So now we're going to replace x squared minus 1 with x plus 1 multiplied by x minus 1. So we have x minus 4 multiplied by x plus 1 multiplied by x minus 1 equal to 0. Now it's important to remember here that for any terms to be, for the product of any terms to be equal to 0, any of those terms can be 0. So let's look at it this way. A multiplied by b multiplied by c equal to 0. For this to be true, a can be equal to 0, b can be equal to 0, and also c can be equal to 0. So we're going to apply that to the factors that we've derived here. So we have x minus 4 equal to 0. We add 4 to both sides. So x equal to 4. We have x plus 1 equal to 0. We subtract 1 from both sides. So x equal to negative 1. Then x minus 1 equal to 0. We add 1 to both sides. So x equal to plus 1. So our values of x, so x is going to be equal to negative 1, 1, and 4. So these are going to be our solutions for x. So these are going to be the roots of this polynomial equation. So now the next question we have is to rationalize these radicals. Rationalize the square root of root 5 plus 2 over root 3 minus 1. So we're going to rationalize the radicals. How would you go about rationalizing radicals? You always need to figure out what the conjugate of your denominator is first. So what is the conjugate of your denominator? The conjugate of your denominator, you always start from there. So how do you identify the conjugate? You're looking for, this is the formula that you need to think about. You need to remember this. A squared minus b squared is a plus b multiplied by a minus b. You always have to remember that. So when you have the square root of 3 minus 1, your conjugate is going to be, you're going to keep your radical, and then you change the sign to a plus, because what ends up happening here is, with this, in this form, you're going to end up squaring this and squaring that and then subtracting. And you're going to see that you're going to have an integer, a rational number. Okay, so let's go ahead and try this out. So square root of 5 plus 2 divided by square root of 3 minus 1. We're going to multiply by the square root of 3 plus 1, the square root of 3 plus 1. And so now we have, the reason why we do this here is because the square root of 3 plus 1 divided by the square root of 3 plus 1 ends up giving us 1. So it gives us 1. So we're multiplying this by 1. And if you remember your identity for multiplication, anytime you multiply a term or a value by 1, you get that same value. So in other words, we're not really changing the value of the original equation. So now we're going to go ahead and multiply across. So this is square root of 5 plus 2 multiplied by the square root of 3 plus 1 over the square root of 3 minus 1 multiplied by the square root of 3 plus 1. So now let's go ahead and multiply this. We're going to FOIL this, make it easier to understand. So the first terms, the square root of 5 multiplied by the square root of 3, that's the square root of 15. Then we're going to have the square root of 5 multiplied by 1, so plus the square root of 5. Then the square root of 3 multiplied by 2 plus 2 square root of 3, and then 2 multiplied by 1 plus 2. So this is going to give us a squared minus b squared. When you have in this form a squared, so it's going to be square root of 3 squared minus 1 squared. So let's group common terms in the numerator. We have square root of 15 plus square root of 5. So we have no common terms here. So we're going to have the square root of 15 plus the square root of 5 plus 2 square root of 3 plus 2 divided by the square root of 3 squared is the square root of 9, which is 3, minus, and then 1 squared is 1. So we now have square root of 15 plus square root of 5 plus 2 square root of 3 plus 2 all divided by 2. So that is the solution to this. Another way you could write this is you could write it as 1/2 of square root of 15 plus square root of 5 plus 2 square root of 3 plus 2. And these are exactly the same values. So it depends on how your teacher wants you to write it or how it's written in your answers. If you have this for a multiple choice question, it depends on how the answer is presented. Some may present it this way, others may present it this way, but just want you to know that these are exactly the same values. So I had some some puzzles for the group, but I'm not getting much participation today. So I would go ahead and put the puzzle out there and see if anyone is willing to participate. And then after that, we can call it a session for today. And this video will be posted up so that you can have it as a reference. So what is the missing value here? We have 5 plus 3 is 16, 7 plus 3 equal to 40. Then what is going to be 9 plus 3? So when you have this, what would be the value of 9 plus 3? Let's see if we're going to get some responses. Otherwise, I can show you what this is about, and then we can call it a session. Five plus 3 is equal to 16. 7 plus 3 equal to 40. Then what is the value of 9 plus 3? All right, let's go ahead and look at it. So what we have here is 5 squared minus 3 squared. That's going to give us 25 minus 9, which is 16. And then 7 squared minus 3 squared is going to give us 49 minus 9, which is equal to 40. So 9 plus 3 is going to be 9 squared minus 3 squared, which is 81 minus 9. That is going to give us 72. So that's really all this was about. Okay. Thank you for joining. Those who have joined our session today, really appreciate your time. Look forward to our session again on Thursday for the 8th to 12th graders. Feel free to send us any questions that you may have before the session starts. This video will be posted up shortly. Feel free to post some questions in the comments for this video, or if you have any feedback, let us know. how this could be more beneficial to you. Thank you. Have a wonderful day, and we'll see you again soon. Bye for now.